Okay, there was 2. Let's move on to number 3. This one's a story problem. You have to write an inequality that describes the situation. So the SS Rebecca Black has lifeboats. They have 24 feet of seating space. Adults take up 3 feet of space, and the children take up 2 feet. Okay, and it says that lifeboats should always have at least one adult in them, right? Can you imagine having a bunch of kids rowing a lifeboat? Anyway, we have to write down inequalities that describe the situation, and then use those inequalities to graph it. So look for requirements and look for restrictions. The lifeboats here have 24 feet of space. That's a restriction. Okay, so we're going to get 24. And what takes up the space? You'll put that over here. Okay, 24, you want less than or equal to, because you can't have more, you can't use up more space than there is available. So this here is how much space is being taken up. That has to be less than or equal to 24. We need 2 variables. Oops. Let's have x be the child's, like how many kids, and let y be the number of adults. Okay. I'm using x and y just because I know I have to graph it. So we'll have x and y. Both the children and the adults take up space, so we're going to use both x and y. Kids take up 2 feet, so we're going to do 2 times the number of children. And we'll add 3 times the number of adults, that's 3y, because it's each adult takes up 3 feet of space. So we got one inequality ready to go, at least that's done for this one. Now you have to find the other restriction or requirement, and that comes from this sentence here. Lifeboats should always have at least one adult in them. So your number of adults, that's y, needs to be greater than or equal to 1, because you can't have anything less than 1 as far as adults are concerned. So this one is ready to go. It's actually ready to be graphed right now because it's solved for y, but this one is not. Okay, we have to get it solved for y. So subtract 2x. Oh, by the way, like this would be the answer to the first part, and then we're solving now so we can graph it. And so that's the next part. Okay, subtract 2x from both sides because we're trying to get y by itself. You got 3y is less than or equal to 24 minus 2x. You got to get y by itself, so divide by the 3. Divide everything by 3. You get y is less than or equal to 24 divided by 3, which is 8. And then subtract 2 divided by 3, which is going to be negative 2/3 x. Okay, so now we got our 2 inequalities solved for y and they're ready to be graphed. Hold on, let me pause. Okay, when you're graphing these, I did give you a grid rather than like a coordinate plane. That's because I wanted you to make your own axes. So when I made these axes here, these are my y's, the number of adults, and x here, the number of children. I looked at my inequalities, and I noticed that this one has a y-intercept of 8. So I need to get up at least 8 high. So when you're making your coordinate plane on it, you won't want your axes to be in the middle like that, because you'll run out of room. And also, it doesn't make sense to have negative adults, like to be over in this region or over here or even down here, because you can't have negative children. You can't have negative adults on a lifeboat. Okay? And so I set up my axes this way on purpose. Okay? So I'm going to graph this blue one in blue. It has a y-intercept of positive 8. So put a point there. And has a slope of negative 2/3. So go down 2 as you go right 3. 2/3. Go down 2 as you go right 3, and you get more points. Okay, it is less than or equal to, so make that a solid line as you draw that. And like I said, it's less than, so you're going to shade below. And really, you don't need to go beyond the axes because it doesn't make sense to have less than 0 children. Okay, I'm going to graph the red one in red. The line y equals 1 is a horizontal line at 1. Okay, it looks like that. Because that's where y equals 1. It looks like that. Okay, this one is greater than, so you will shade above, like so. And make sure you make the double shaded region darker. And that's that one. Okay, and that one's all graphed and done.